All right. Okay, copy this down first. Okay, which part is u?
X squared plus 1.
Good. What is du?
2x dx.
2x dx. Okay, so let's see. What do I need to do to kind of fix it?
1/2.
Okay, 1/2 du and equals x dx. Okay, so now let's kind of plug that in. So what does my integral become?
1/2.
Okay, 1/2 u cubed du. Good. Now, the tricky part about this is the limits are not going to stay as 1 and 3 because the limits are for x. You changed everything to u, so obviously they're not the same. Therefore, you need to change the limit. So, your limits were from 1 to 3. Yes, so now you know that u is x squared plus 1. You need to change it. So u is equal to x squared plus 1. So that means it's 2. Okay, so again, your integral was in terms of x. When you change it to u, it's obviously not the same numbers anymore, right? We're in a different dimension now, right? So then you got to change your limit. It's not from 1 to 3 in terms of x. You have to change it to something that's in terms of u. Okay, so you make sure you do change that. Okay, so in the x world, I guess, when x is 1, in the u world, it's 2. In the x world, when x is 3, u is equal to x squared plus 1, so that is 10. Okay, so now we're going to change the limit from 2 to 10. All right, so here's another thing that you need to be aware of. This is a little tricky. 1 is 2. 3 is 10. Okay, you need to make a direct substitution in. If this number becomes a smaller number than the top number, you got to stay as is. You do not change the direction because you want to. Okay, it has to be a direct substitution. I'm going to show you another example that has that problem. Anyways, let's just solve this one. Okay, what is a good guess on the integral of u to the fourth? 1/4 u to the fourth. Okay. All right, so this is going to be 1/2 that was on the outside of the integral. And then my integral of u cubed is 1/4 u to the fourth, evaluated from 2 to 10. When you evaluate integral, you always want to bring the coefficients in the front. You don't want to bring it with you to evaluate because it just creates a lot of calculation problems. So it's just 1/8 u to the fourth, evaluated from 2 to 10. Okay, that's going to be 1/8. Sorry, that's a 10. 10 to the fourth minus 2 to the fourth.
Oh, what?
Do you not plug in x squared?
What x squared?
It's not just, but it's not 10 to the fourth times 1/8 minus 2 to the fourth times 1.
It is, but I'm going to leave the 1/8 outside so I don't carry it with me on all the calculation. It's just too much work. Okay, so this is going to be 1/8. 10,000 minus 16. What?
12 and 48. 1,000.
Okay, 1,000 minus 16 is what? 9984. Yeah, 84 over 8. Oh, 1248?
Something.
It is something. 1248.
Will we get our calculators for this one?
All right.
Clearly 1248.
Okay, so let's go ahead. Okay, let's go ahead and try another one. This one is the tricky one. Okay. Let's try it together. Which part is u? 3 minus 5x.
Because
Which part is du?
dx.
No.
Negative.
Negative 5 dx.
Oh, shoot.
That's
Oh,
right.
Okay.
that was x squared.
Go, go ahead and plug it back in. So first you divide by 5, so then you get 150u is equal to dx, and then you can make a substitution. This is going to be 1 over u squared with a negative 1/5 on the outside and then du. Okay, we're going to have to change those limits 1 to 2. Question?
Well,
No.
I want to see.
Okay, so x is equal to 1 and x is equal to 2. Okay, so we know that u is equal to 3 minus 5x. So that is 3 minus 5 times 1. That is minus 2. U is equal to 3 minus 5 times 2. That is minus 7. Okay, remember what I tell you about plugging it directly? This is minus 2, this is minus 7. If you don't do that, if you just want to put the smaller number on the bottom, it will totally be wrong. So I'm going to tell you this. Please be careful. It's a direct substitution. 1 is negative 2. It goes on the the 1 spot. It's just replacing it. Now, can you integrate like this? No, because we always integrate with a small number first. So how do I switch them so the smaller number goes first?
FTC part 1.
Huh? Negative. So it was one of the rules of integral. If you have the integral from a to b of f of x, and for some reason you want to switch it so it's b to a, you have to make it negative. Yes?
Why can't you just do like FTC or just like what we did earlier where we just subtract?
Yes, you can. I think it's still going to be the same. Because you're taking a smaller number minus a bigger number. Yes?
So we just make 1/5 not negative.
Yes. So remember you're going to, but you have to remember this rule because it's going to come up in something. If your limits are not in the way you want them to be, you want to switch them, you got to make that integral negative. Because usually when you integrate, you're going from left to right. Now you're going to integrate from right to left. You're going the backwards direction. So your areas are going to be negative. Okay, so I'm going to change this so it's negative. So it's 1/5 from negative 7 to negative 2 of 1 over u squared du. Okay, go ahead and integrate, and then you're going to evaluate. Remember my trick about integrating and evaluating is that take all your coefficients, put it outside. Don't come with all your evaluation. You're going to make a lot of calculation mistakes. Does that make sense? That 1/5 stays outside, and whatever constant that you have stays outside, and then evaluate. Okay, go ahead and do this one. Let me know when you have your answer. Okay, so the answer is 1 over 14. This one says integrate, but let u equal 3t minus 1. So this tells you that u is equal to 3t minus 1, so then du is 3 dt. Okay, we don't want that 3, so 1/3 du is dt. Okay, so let's go ahead and change it. So this is going to have a 1/3 outside, u to the 50th du. The limits are going to change. If you didn't change the limits, you're going to get something that's not correct. Your limits were 0 to 1. You're going to change it to u. U is 3t, I'm sorry, not x. T. Okay, u is 3t minus 1. So this is minus 1, and this is 2. So then our limits are going to change. It's going to be from negative 1 to 2. Okay, now you evaluate. So 1/3 stays on the outside. U to the, we need to integrate first. Okay, 1/3, this is going to be u to the 51st over 51. Evaluate it from negative 1 to 2. So this is going to be 1/3. 2 to the 51 over 51 minus negative 1 to the 51 over 51. So this is, 21. I'm going to take, I'm going to take the 1 over 51 outside, so this is going to be 1 over 3 times 1 over 51 times 2 to the 51, negative 1 to the 50th first power. It's an odd power, so that stays negative, so this is plus 1. Yes?
Why didn't you plug 3t minus 1 into u?
I just need to evaluate. So then I'm going to evaluate everything in terms of u, since I already figured out what u's limits are.
Oh, got it.
Okay, yesterday you did indefinite integral. Indefinite means there are no limits. When there are no limits, you're just solving with something with a plus c. When it's a plus c, yes, you plug it back in. But today we're solving with definite integral. Definite integral means that there are two numbers here. You're trying to figure out the area under the curve between these two numbers. So instead of plugging it back in and then using 0 to 1, I could just evaluate in terms of u, but then I gotta change that limit. Okay. Questions? Okay. If you have questions, you gotta ask, because we're gonna progress and it's gonna get harder. If you have questions right now, it's just gonna multiply roll like a snowball, and it gets really, really bad. Yes?
Oh, so technically, could you still do it like the old way?
Yeah, you can. So you don't have to change it to u. You could just leave it like this, 1/3, and then we had u to the 51 over 51, right? We could just put it back, and what was it? 3t minus 1. 3t minus 1 to the 51 over 51. Put it back, right? And then I would just evaluate from 0 to 1. It's the same thing. You're going to get the same thing. I think it's not faster this way because your numbers are bigger. Yes?
Do it without u.
Can you do it without u? Yes, you can totally just guess. Make a guess.
Oh,
What do you think the integral is?
1 over 51.
Yeah, 1 over 51, 3t minus 1 to the 51st power. But there's a chain rule times 3, so you got to get rid of that 3. Yes, you don't have to do u sub. Okay? All right, let's try another one. This one. The answer is 1/2. Okay, so there were a lot of issues around. So finally, people figure out that u has to be natural log. And then we have an integral of u. And then people did not integrate. So there were a few people who didn't integrate. And then you just plug in 0 to 1 and not good. Okay, so let's kind of practice this. If f is even, what does this equal to? If f is even, all right, something. If f is even, that means the graph is going to be reflected over y-axis, right? From negative a to a, this is the same as evaluating from 2 times 2 times the integral from just 0 to a. Okay, you're gonna have to try to keep that in mind and then use these tricks to help you. Because sometimes it's easier to see the symmetry and find the answer that way than go through the whole thing and you realize, oh, I could have done that. You want to solve it faster. Okay, if f is odd. Yes, so if f is odd, that means the graph is like that. Yes.
Is that like a trick? Or?
It is a trick. Yes. So when you have a limit to a limit where they're opposite signs, they're basically the same distance from 0. So you could use this trick. If this is negative a and this is a, then this is going to be 0 because they will cancel each other out. Say that again.
Okay, please go back up to the.
Okay, so now the question is, how do you figure out if it's odd or even if you don't have a graph? Let's recall. Odd function, how do you check to see if a function is odd? F of negative x is what?
Equal to negative f of x?
Negative f of x. Okay, so everything you learn in pre-cal, you gotta remember.
That sounds so easy.
That's easy.
Well, I'm gonna remind you throughout the year. Okay, even f of negative x is what?
Equal to f of x.
F of x. Okay. If you don't remember that, write it down, keep it in mind. Okay, sorry. Guys are copying it down. Okay, let's solve a few problems. So these you want to try it with your partner. Okay, check this one. Okay, so this question, so hopefully you can see the symmetry. So this is going to be 2 times the integral from 0 to 2 of x to the 6 plus 1 dx. All right, this is just going to be 2 times the integral, which is x to the 7 plus x, evaluated from 0 to 2. Okay, 2 times 2 to the 7th over 7 plus 2 minus 0. Right, so that whole thing is 0, so I'm going to just ignore that. So this is 2 times 2 to the 7 is 128 over 7 plus 2. Okay, 2 times 128 over 7 plus 14 over 7. Okay, 142 over 7. 284 over 7. All right, let's try one last one. Okay, let me show you how to check. Oh my gosh. Okay, so, all right, so f of negative x. Okay, tangent of negative x over 1 plus negative x squared plus negative x to the 4th. Tangent is an odd graph, so that means negative comes out. Everything underneath is always going to be squared, so then this is odd, so it's 0.